Okay, this is for week 3 Tuesday class. So we basically finished our discussion on tangent portfolio in the last class. So today let's continue to our discussion on how could we get to capital asset pricing model. So the first step is we would want to understand the efficient portfolio and the required returns. So this is the section 3. What is the question here? Well, the question here is, let's say we have a portfolio P, which is inefficient. So it is inefficient. And now we want to do something to make this portfolio more efficient. So what's our choice here? Now think about this. This is your portfolio P, and it contains different investments, right? So you could imagine that if this portfolio is a stock portfolio, it could have Google, Apple, Amazon, Tesla, all different kinds of stocks from different companies, right? So let's say we want to focus on a particular investment or particular stock I, right? So now we want to think about how could we adjust our investment in investment I to make the portfolio P more efficient, right? So again, now our question is, how could we adjust investment I to make portfolio P more efficient? To think about this question, we basically need to consider the relationship between expected return and the required returns. And to understand required return, we have to first define beta. Here I would say this is the first time we define beta. And beta plays a very important role in the capital asset pricing model. So it's important for you to understand how to define beta and how to calculate beta. So here we define beta of investment I with respect to portfolio P. Note here the definition of beta depends on portfolio P, right? So it is function of both investment I and portfolio P. What's the definition here? So basically the most basic definition is beta I with respect to portfolio P equals covariance. So we are looking at this term here equals equals covariance between the return of investment I and the return of portfolio P divided by the variance of the return of portfolio P. And if this is the most basic form of the definition, we could basically have a alternative form here. So according to the definition of correlation, we know that covariance, right? Covariance could be written as the product of correlation and standard deviations. And of course, variance could be written as standard deviation squared. And here you can see that this is a very simple mathematical manipulation. That is, you could basically cancel out standard deviation RP and standard deviation RP. So what's left is this term, right? So it's standard deviation of investment I's return times the correlation between investment I's return and portfolio I's return divided by the standard deviation of portfolio P's return. Obviously, you could have both ways to calculate beta. So both are correct. I also want to make a comment that this beta is related to portfolio P. If you have a different portfolio, let's say this is portfolio P and this is portfolio Q, they both have investments I. Then in this case, you would calculate beta IP and beta IQ. And if P is not equal to Q, then generally beta IP is not equal to beta IQ. Okay, now we could formally talk about how could we adjust the investment I to make portfolio P more efficient. As I said, you want to compare the expected return of investment I and the required return. So let's call this whole formula as required return. Right. So required return is calculated by this formula. I know I have not told you why you should calculate required return in this way. This is not a math course. There is some rigorous mathematical manipulation to get this result. And I think the textbook gives you some sort of mathematical process. You could look at it and to get some understanding if you're interested in how to get this formula. But here, I'm just telling you that you should use this formula to calculate required return. So, a basic result of making portfolio more efficient is like this. If investment I's expected return is larger than its required return, then increasing your investment in investment I will make your portfolio P more efficient. And similarly, if the expected return of investment I is smaller compared with its required return, then reducing the amount invested in investment I will make your portfolio P more efficient. Right? So basically, okay, maybe it's worth writing down this result here. So basically there are two cases. You would compare expected return versus required return. And if the first case, that is expected return larger than required return, if it's larger than required return, then you would increase your investment in stock I. In this case, portfolio P would be more efficient. And if the expected return of investment I is smaller compared with required return, in this case, you would reduce your investment or your money in investment I. In this case, P would be more efficient. I just want to give you a simple intuition why this would hold. The simple intuition is somewhat obvious. Well, because you're comparing expected return versus required return, right? So basically it means that if expected return is larger than required return, it's as if this is a good investment, right? It's a worthy investment. So you would want to invest more. And this would make your portfolio P better, right? More efficient. And if expected return is smaller than the required return, the required return is sort of like a cut-off value, a threshold, right? So it means that its return does not meet its threshold. In this case, it's as if it's a bad investment. So you want to reduce your money invested in this bad investment. So this would surely, clearly make your portfolio P better, right? More efficient. Okay. Let's see this example here. Now let's say now you're investing in the so-called Omega fund, right? So this Omega fund, this is your original investment. And this fund has a expected return of 15% and a volatility of 20%. Let's say the risk-free T-bills pay you 3%. Your broker suggests that you add a real estate fund to your portfolio. And this real estate fund has an expected return of 9%, a volatility of 35%, and a correlation of 0.1 with the Omega fund. The question is, will adding the real estate fund improve your portfolio? So this is about portfolio improvement. And we just learned to understand or to answer this, you want to compare expected return of investment I versus its required return. Here, which one is investment I? Well, it's the real estate fund, right? So here you want to think about the expected return of the real estate fund versus its required return. Now, obviously, the expected return of real estate fund. So let me use RE to represent the real estate fund. The expected return of the real estate fund is, let me see which number I should use here. Oh, it's 9%. Right? So now I want to calculate what's the required return, right? So let's call the required return as lowercase r. Right? And we have just learned we could use this formula to calculate required return. And this RF refers to risk-free rate, and beta I times the expected return of the RP minus RF. Now, let's see what numbers do we have here. So we clearly have RF, right? Risk-free rate is given by 3%. Now, what is RP? Well, RP is this Omega fund, right? Portfolio P is Omega fund. So RP, or expected return of RP, is given by 15%. And now we want to find out this beta I, right? What is beta I? Obviously, the problem does not give us beta I, but the problem gives us correlation and standard deviations. So we could basically calculate beta I from these numbers. Okay, now let me calculate beta I. So beta I P equals standard deviation of RP, and numerator should be standard deviation of RI times correlation between RP and RI. And in this case, you could see that we have all the numbers we need, right? And here, standard deviation of RI is given by 35%. And correlation is given by 0.1. And the standard deviation of RP is given by 20%. So I guess the beta here is 0.175. Yes, it's 0.175. Now we could plug in all these numbers we have got. So 3% plus 0.175 times 15% minus 3%. So we get a number of we get a value of 5.1%. Now it's the decision time. We find out the expected return is larger than the required return, right? Because we're comparing 9%, right? We're comparing 9% versus 5.1%. And this basically tells us the answer is yes. We should add the real estate fund into the portfolio. It will improve our portfolio. Okay. Now we could finally talk about the relationship between expected returns and the efficient portfolio. And this is actually a quite important result because the capital asset pricing model is basically based on this formula here. So it's like the premise or the root of capital asset pricing model. Now let me first state this result, and then I will give you some explanation why this is true. A portfolio is efficient if and only if the expected return of every security in this portfolio equals its required return. Right? Again, this is an important result, and it tells us when a portfolio is efficient. More importantly, it gives us a formula to calculate the expected return of every security if the portfolio is efficient, right? So let me repeat. Basically, it says that if a portfolio is efficient, then every security's expected return equals required return. And because we know how to calculate required return, so basically this formula tells us how could we calculate expected return of every security in an efficient portfolio, right? So this is nice because this sort of gives you the basis to understand what is the expected return if the portfolio is efficient, right? Now, why does this hold? Why is this true? Well, if you recall what we just talked about, right? If you look at this result, right? It basically tells you that if a portfolio is not efficient, then you will either get the expected return is larger than required return, or it is smaller than required return. Then this tells you that if a portfolio is efficient, then expected return has to be the same as required return, right? Because if expected return does not equal required return, then you should be able to make some adjustment to make this portfolio more efficient, right? This violates the definition of efficiency. Okay, let's say this example here. Oh, this example is not required, but it's worth looking at this solution here. Okay, consider the Omega fund and the real estate fund we just talked about. Suppose you have $100 million invested in the Omega fund. In addition to this position, how much should you invest in the real estate fund to form an efficient portfolio of these two funds? So if you recall the previous example we just talked about, the answer we got there is we know that we should add real estate fund into this Omega fund to achieve a more efficient portfolio. So now the question here is a deeper question, right? It asks how much should you invest? And you can see the algebra here. You have to be able to solve a relatively complicated one variable equation to get your result. So let's skip this part and let's just resort to the table here and understand what this table is doing here, right? So let's look at these columns. So the first one is the portfolio weight. It's essentially the portfolio weight of real estate fund, or how much money or the percentage you want to put into this real estate fund. And given the portfolio weight, obviously, we should be able to calculate the combined portfolio's expected return and the combined portfolio's standard deviation. It's a combined portfolio because remember, now we are investing money in both the real estate fund and the Omega fund. And after getting the expected return and the standard deviation, we should be able to calculate Sharpe ratio, right? So for example, in this case, for the first line, the Sharpe ratio is 0.6. How do you calculate this? Well, by definition, right? So let me show you how do you calculate Let me show you how to calculate Sharpe ratio here. Okay, so by definition, it's the expected return minus the risk-free rate divided by the standard deviation. So we know the risk-free rate is 3%. So it's 15% minus 3% times 20%. It's 0.6. So that's how you get 0.6 Sharpe ratio. And you could also calculate the correlation between the real estate fund and the combined portfolio. And now you could also calculate beta. So how do you get beta? Well, we know how to calculate beta, right? We just learned about this. Okay, let me show you how do you get this 0.18. So it's given by correlation times standard deviation of real estate fund and the standard deviation of the portfolio. If we plug in numbers, correlation is given by 10%, right? So it's 0.1 times standard deviation of the real estate fund. Oops, what's the standard deviation of real estate fund? Oops. So it's given by this, right? 35%. So we have 35% here. And divided by the standard deviation of the combined portfolio, which is 20%. Right? So now we get 0.175, which is roughly 0.18. Okay. Now we could calculate the required return, right? Well, required return is easy. Let's see how could we get 5.1 here. So required return equals risk-free rate plus beta times expected return of the combined portfolio P minus risk-free rate. So it's 3% plus 0.18 times 15% minus 3%. So this gives us 5.1%. Okay, great. That's the part about how to calculate these numbers. Now let's see more interesting stuff. We want to see some patterns here. That is, we want to see how changing the portfolio weight would affect the required return and Sharpe ratio. Right? So let's see here. What you're doing here, you're increasing your weight on the real estate fund. And now you can see that as you increase your portfolio weight on real estate fund, you can see that the Sharpe ratio first increases, right? This is like the maximum Sharpe ratio. And then it actually decreases. And what about the required return? Well, required return first increases. Then it increases to this 9%. And past this value, it continues to increase, right? Now, how do you know this is the best portfolio weight, 11% you want to use? Well, because we know that the real estate fund has an expected return of 9%. So we want to look at the required return and we want to find the number which is almost exactly 9%. So in this case, this number, this is the number we want, right? This is the number we want. And from this table, we can tell that this is the best combination. That is, you want to have a portfolio weight of 11% into this real estate fund. And you can see that at this portfolio weight, Sharpe ratio reaches the largest possible value, right? It's 0.6104, which is larger than all other Sharpe ratios. And this is quite easy to understand, right? Because we have learned in previous class, when we were talking about the tangent portfolio, the tangent portfolio should give you the largest possible Sharpe ratio, right? So in this case, if the portfolio is efficient, it should give us the largest possible Sharpe ratio. Okay, great. Now we could finally talk about this. I would say it's super important model, right? This capital asset pricing model. There are multiple asset pricing models in finance literature. The Kapam was like the first one, and it's the most widely used, the most famous one. It has its shortcomings, but maybe due to conventions or due to historical reasons, it is really popular. Okay, so if you look at the name, right, you could see that this model is about pricing capital asset. In plain English, this model basically tells you the expected return of a certain asset. And because expected return is the same as cost of capital, it's the same thing. So basically you can see that using capital asset pricing model, you could find out the cost of capital for a certain asset. This is nice because in corporate finance, when you're calculating the net present value, you always want to find out what's the correct discount factor, right? And if it's risk-free, you could just use the risk-free rate to calculate the risk-free, the correct discount factor. But if the project, if its cash flows have risk, then you have to make some adjustment. So how do you get the correct discount factor when the cash flows are risky? Well, you could use Kapam. You could use this capital asset pricing model to find out the correct discount factor, the correct cost of capital. So that's why this Kapam is also very useful in corporate finance. Right? Okay, well, now let's start talking about this very important model. So the first step to talk about this model is we wanted to find out what is this efficient portfolio is about. Well, why this is important? If you recall what we have just learned about the efficient portfolio and expected return, you can see that if you want to find out the expected return for any asset I, you have to calculate the beta And you also have to find out what's the expected return of the efficient portfolio, right? However, what is a efficient portfolio, or how can we find out a exact portfolio which exists in reality, which is also efficient? How can we find such a portfolio, right? This is important, right? Because only with a efficient portfolio we could use a formula like this to find out the expected return of investment I. Right? Okay, that's a little bit of motivation here. And what's the difficulty in finding out this efficient portfolio? Well, think about think about this. What is a portfolio? A portfolio is a collection of different assets, right? This implies that if you want to find out the expected return and the volatility of this efficient portfolio, then you have to find out the expected return, volatilities, and correlation between all different investments in this efficient portfolio. Right? Okay, let me draw a little picture to show you why this is difficult, right? So let's say this is our portfolio, right? So this is our portfolio. So let me be generous. Let's say this is a efficient portfolio. And this efficient portfolio has a lot of investments, right? You can see that I am putting a lot of dots within the circle. So it has let's say this efficient portfolio has, I'll just put some number here. Let's say we have 1,000 different investments. And the first step to use the formula we just learned about this is we have to find out beta, right? To find out the beta, a basic question is we want to ask what is the standard deviation of this efficient portfolio's return? And to calculate the standard deviation, we have to calculate the variance of this efficient portfolio's return. And to calculate the variance, then this task becomes complicated, right? If we want to find out the variance of the portfolio P, we have to understand the volatility of each individual investment and the correlations between each individual investments, right? So we have to know 1,000 volatilities, right? Because we have 1,000 individual investments, and we also needed to look for correlation between each different investments, and we actually have to look for a number which is much larger than 1,000, right? So this is a hard task, and now we wanted to make our life easier. So we want to make the following claim. We claim that efficient portfolio is the market portfolio. First, what is a market portfolio? Well, it's the portfolio of all stocks and securities in the market, right? This is nice because if efficient portfolio is the market portfolio, then we could just use the market portfolio to represent the efficient portfolio. So the standard deviation of the efficient portfolio is essentially the standard deviation of the market portfolio. Right? Now, how could we get this important result? Right? How could we, under what assumptions we could claim that efficient portfolio is the market portfolio? Well, we have to make several assumptions. This section is a little bit of theoretical, but I think it's interesting, and it also gives you it also gives you the some intuition why we could consider market portfolio as efficient portfolio. Okay, now let me first state the three main assumptions. The first assumption is investors, they could buy and sell all securities at competitive market prices, and there are no taxes or transaction costs, and they could borrow and lend at the risk-free rate. I don't want to state or talk too much about this assumption, but this assumption basically guarantees there are no limits to arbitrage. So the law of one price can actually hold in the financial market. Now, assumption two, investors hold only efficient portfolios of traded securities. This is actually a strong assumption, right? So it basically says that every investor is smart. Every investor is fully rational. Every investor would hold the best portfolio, that is, the efficient portfolio. Now, assumption three, investors have the same expectations about volatilities, correlations, and expected return of all securities in the market. So why do you need assumption three? Well, assumption three will guarantee that all investors will hold the same efficient portfolio. So basically, assumption two tells you that investors will hold efficient portfolios. And under assumption three, because investors have the same expectations about the future, so every one of them will hold the same efficient portfolio. Now, what does this? Now, you can see that assumption three is actually very, very strong because it assumes that investors have homogeneous expectations, right? They all have the same expectations, which is obviously not true. But how do you justify this? Well, the textbook gives you some explanation. Why could you make an assumption like this? So it basically says that generally, investors, they will look at the past history to think about the future. And generally, past histories are roughly the same for all investors. So investors should roughly have the same expectation about the future. Obviously, this is not entirely true, but this assumption helps us to get our result. Okay, now, under these three assumptions, we could reach the result. That is, market portfolio is efficient. So why? Well, this page gives you the reasoning here. Roughly speaking, market portfolio is efficient. This is because, first, we know that all investors, they will hold the same efficient portfolio. This means if we combine all investors' portfolio, then this combined portfolio must be efficient. And what is this combined portfolio? Well, if you combine all investors' portfolios, then this combination is just market portfolio. So if the combined portfolio is efficient, then market portfolio has to be efficient, right? So the basic logic here is demand equals supply. What is demand? Well, demand is the combined investor portfolios, right? So what is supply? Supply is market portfolio. And if combined investor portfolios are efficient, then because demand equals supply, the market portfolio must be efficient. Okay, now let's see this example here. Suppose you have identified the efficient portfolio, and as part of your holdings, you decide to invest 10,000 in Microsoft, 5,000 in Pfizer. Suppose your friend, who is wealthier, more conservative, blah blah, which is not important here, has 2,000 invested in Pfizer, right? Now let's assume your friend is also rational and smart, so her portfolio is efficient. Now the question is, how much has she invested in Microsoft? Right? The second question is, if all investors are holding efficient portfolios, what can you conclude about Microsoft's market capitalization compared to Pfizer's? Okay, so here we have two people, you and your friend, and you're investing in two stocks. The first one is Microsoft. Microsoft. And the second one is Pfizer. So you would invest $10,000 in Microsoft and $5,000 in Pfizer. Your friend invests $2,000 in Pfizer. Now the question is, what is the amount she has invested in Microsoft? Right? Now, how do you solve this? Well, we know that under the assumption of Kapam, every investor should hold the same efficient portfolio, right? So that's the basis to solve this problem. Now, what does the statement every investor holds the same efficient portfolio means? Well, the same does not imply you're investing the same amount of money as your friend. It implies the portfolio weight of your portfolio should be the same as the portfolio weight of your friend's portfolio. So that's what the same efficient portfolio means, right? Again, if investors, they're holding the same efficient portfolio, then the portfolio weights of each individual investor's portfolio have to be the same. Now this could help us to solve this problem, right? You can see that you invest twice your money in Microsoft. Now this implies that your friend should also do the same. So your friend should invest twice the money into Microsoft, which means you should put number 4,000 here. Now, the second question. What can you know about Microsoft's market capitalization compared with Pfizer's? So here you can see that you're investing twice the money into Microsoft compared with Pfizer. Your friend is doing the same. And if in the market, every investor is holding the same efficient portfolio, then this implies that every investor should hold twice the money in Microsoft compared with Pfizer. So this implies that Microsoft has twice the market cap compared with Pfizer's. Right? So the answer to the second question is Microsoft has twice the market cap compared to Pfizer. Okay, great. Okay, so we basically now obtained this important result. That is, market portfolio is efficient. And we also learned about in the last class, we know that tangent portfolio is the efficient portfolio. So if you combine these two results, now we could know that the market portfolio is the tangent portfolio, right? So if we go back to last class, then we talk about this nice picture, right? We talk about this nice picture here. So basically we said, okay, if you have a tangent portfolio here, and you have a risk-free investment here, then this line gives you the efficient frontier, right? So now we know that market portfolio is the tangent portfolio. So we could actually directly call this portfolio as market portfolio, right? So that is what this slide is about, right? So this slide basically call this tangent portfolio as market portfolio. And you can see that now again you could do the same thing, right? Connect the risk-free investment and the market portfolio. You will get a straight line, which is again this efficient frontier. And this line is called capital market line, right? Okay. Now we could talk about, by the way, I should mention this. So under the assumption of capital asset pricing model, because tangent portfolio is the market portfolio, then you would imagine that in such a world, every investor will hold only two portfolios, right? Every investor will hold risk-free investment and market portfolio. And we have made this statements before. That is, if you're very aggressive, right? If you're very aggressive in taking the risk, so you will be on this part. You will essentially borrow money to invest in the tangent trade. You will basically borrow money to invest in the market portfolio. And you can see that it's risky because here, if you're on this side, you can see that you have higher volatility and you're also compensated with higher return. Now, if you're more conservative, right, you will still hold the market portfolio and risk-free investment. Now you will just be on this side, right? For example, if you're here, you're essentially investing 50% of your money into the market portfolio and the other 50% in this risk-free investment. So here what I'm saying is basically what exactly your portfolio will look like depends on your risk preference. Okay, now we could formally talk about or introduce this capital asset pricing model. The short name is Kapam. So Kapam basically tells you how you could calculate the cost of capital for a investment I. You can see that the expected return of investment I or the cost of capital for investment I equals risk-free rate plus the beta of investment I with respect to the market portfolio times the expected return of the market portfolio minus the risk-free rate. This whole part is called risk premium for security I. Well, why this is a risk premium? Well, because it's the amount, it's the additional return you can get above risk-free rate, right? So this is the risk-free rate. So risk-free rate plus the risk premium gives you the expected return. And it is a risk premium. It's also because you can see that it's beta times something. What is beta? The beta essentially measures your risk exposure, right? So you can see that beta times something times the expected return of the market minus the risk-free rate should give you the risk premium. Okay. Obviously, it's important to learn how to calculate beta. Well, we have learned about this, right? And the calculation of beta is quite similar to the previous formula here. So it's the correlation between the investment I's return and the return of the market divided by the variance of the return of the market. Obviously, right? You could obviously, you could also have this formula here. And it's also important to remember that the expected return of the market minus the risk-free rate has a name, market risk premium. It's a risk premium because it's the amount above the risk-free rate. Okay. So the Kapam gives us the security market line. Security market line is really the graphic representation of the Kapam model. Now, how do you draw this? How do you draw out this security market line? Well, if you look at the Kapam model, so expected return of our I equals our F plus beta I and the market risk premium. Now, if you think about the high school math, right? So let's start with the simple case. So y equals 1 plus 2x. Now, how do you draw out this function? Well, you would know that if you put x on the horizontal axis, y on the vertical axis, then the vertical intercept is given by 1, and this curve, this line, has a slope equals to 2, right? So this is the vertical intercept. 2 is the slope, right? Now, having learned about this, we could talk about Kapam model, and we could talk about how could we draw out this Kapam model. So here you can see that let's say, okay, let me give you some numbers, right? Let's say the risk-free rate is 3%. And let's say the expected return of the market is 10%. Now you can see that the Kapam model can be simplified as ERI equals 3% times 10% times beta I. Now how do you draw out this Kapam model? Well, it's the same thing here, right? Sorry guys. Now it's the same thing here, right? To draw out this, what you're gonna do is you should put beta I on the horizontal axis and the expected return of investment I on the vertical axis. And now what is the vertical intercept? Well, it's the risk-free rate, right? 3%. What is the slope? Well, slope is given by 10%, which is the market risk premium. So this is called security market line, right? This guy is SML, right? Basically, security market line tells you what's the relationship between expected return, right? Between expected return and beta. Okay, now we're having this nicer security market line here. It's the same thing. as I have just drawn. Now, an important result of the security market line is if Kapam holds, then every stock should lie on the security market line. Right? You can see that in this picture, every stock lies exactly on this security market line. The reason is because if Kapam holds, you can see that this result should hold for any I, right? For any stock I. This means if you draw out, if you look for different stocks, okay, let me remove this part first. So this implies if you're looking for different equities, right? Let's say you're looking for Air Canada, then maybe it's here. If you're looking for Delta Airlines, maybe it's here. If you're looking for Apple, maybe it's here. Right? The important thing is if Kapam holds, then every stock's capital asset price model will have the same 3% and 10%. So if you draw out the expected return of the and beta for different stocks, then they should lie on the same capital asset pricing model. That is, they should lie on the same security market line. Okay, now let's talk about beta a little bit. So basically, beta here in this Kapam model measures the systematic risk. And because it measures systematic risk, then clearly beta does not equal volatility. Right? So beta is not the same as volatility. Well, because we have learned about this, volatility calculates the total risk, right? So volatility calculates the total risk. And we know that total risk contains two parts: systematic risk and firm-specific or unsystematic risk. And beta only measures systematic risk. So obviously, beta does not equal volatility. Okay. Now let's look at some data and understand why we could see different betas for different firms. So this is the table for, I think for Canadian, for Canadian market. So what I can see here is, let's see, so here you can see that for different firms, right, we could have different betas. For example, for this Shoppers, right, its beta is quite small. It's only 0.27. Right? And for, let me pick a firm. For information technology, right? This Celestica, right? It has a large beta. It's 1.1672. So why do you see large differences in firms' betas, right? That's the question here. And we could also see the same result for the US market. Well, this is actually a nicer table because equity betas are ranked from small to large. So you can see that for General Mills, I think it's a food producer, right? Oh yes, it's packaged food. And it has a small beta of only 0.2. And now if you go to Saks Fifth Avenue, right? It's a department store. And its beta is very large. It's 2.57, right? Why do you see a large differences as this? Well, the reason is the size or the magnitude of beta is related to how sensitive this firm's cash flows to economic conditions. We could use these two firms as example, right? For General Mills, it's a food producer. You can imagine that no matter whether the economy is good or bad, people, they would need to buy food, right? So you can see that the cash flows of the cash flows of General Mills are generally smooth and stable, right? And now you can see that for Saks Fifth Avenue, it's a luxury department store. And you can see that if the economy is good, well, people have abundant money, they would buy luxury stuff, right? They could go to Saks, buy Louis Vuitton, or buy some other luxury items. But if economy is bad, then they would just scale back their consumption. They would just maybe not shop at Saks Fifth Avenue. So you can imagine that Saks Fifth Avenue's cash flows are very sensitive to economic conditions. In this case, it will have a large beta. Right? Okay, now let's see this example here. Suppose the risk-free return is 4% and the market portfolio has an expected return of 10% and a volatility of 16.4%. The Forzani group has a 36.89% volatility and a correlation with the market of 0.56. What is the Forzani's beta with the market? And what capital market line portfolio has equivalent market risk? And what is its expected return? Okay, the first question is about calculating beta, right? So we know that beta equals standard deviation of stock I times correlation of stock I with the market divided by the standard deviation of the market return. So I believe we could just directly plug in numbers. So it's 36.89% times correlation, which is 0.56, divided by the market volatility, which is 16.4%. So this gives us 1.26. And the second question is about what capital market line portfolio has the equivalent market risk and what is its expected return. So if you think about the capital market line, right? So we have the risk-free rate here, which is 4%, and we have the market portfolio here. Now, if you look at the beta here, the beta is 1.26. This basically tells you that to get to this level of beta, you have to invest 122% into the market portfolio. Right? What is its expected return? Well, this is basically given by Kapam, right? So the expected return equals to risk-free rate plus beta times the market expected return minus risk-free rate 4% plus 1.26 times 10% minus 4%, which is 11.56%. So you can see that this is actually a quite simple problem. The only caveat here is you have to understand how to calculate beta, right? That's the key step. So after successfully calculating beta, to answer the second question, which is about calculating the expected return, you just directly apply capital asset pricing model. Oh, we still have one more question. So suppose the stock of S&C has a negative beta of minus 0.17. How does its required return compare to the risk-free rate according to the Kapam? Does this result make sense? Well, we have some additional data here, right? So the risk-free rate is 3%, expected market return is 8.5%. Okay, now let's answer the first question. What is its required return compared to the risk-free rate according to Kapam? Again, it's just about directly applying Kapam to find out the expected return. So this firm's so S&C's expected return equals 3% plus beta, which is a negative number, times 8.5% minus 3%. I will skip the exact calculation, but you can see that this is a positive number and this is a negative number. So what you can see here, it's smaller than 3%. Okay, I just copy the. So it's 2.065%. It's about 2%, which is smaller than 3%. This is somewhat weird, right? Because generally, when you're making investment, you're actually expecting a return which is higher than risk-free rate. But now, the opposite happens. You can see that your investment gives you a return smaller compared with the risk-free rate. Now, does this make sense? Well, this is a very special case, and it does make sense. It makes sense because this stock has a negative beta. Generally, you're expecting a higher return compared with the risk-free rate because the beta is generally positive. And in the case of negative beta, then you will just require a return smaller than the risk-free rate. Why this would happen, right? Well, it's because if it has a negative beta, intuitively you can consider that this stock has a negative correlation with the market. It basically means that if the market drops, S&C's stock will increase. So the implication of this price behavior is S&C stock serves as the insurance to the market portfolio. So this implies that on a bad day, your life will not be that bad because you have S&C stock, right? Because it will give you some positive return on a bad day. So this insurance has value. So that's why in order to getting this insurance, you will just require a 2% return. That's the intuition here. Okay, let's see what's. Oh, okay. Now we talk about the beta of a portfolio. So we basically only talked about the beta of a single investment, right? We know how to calculate it. But now, how do you calculate the beta of a portfolio? Well, it's pretty simple as long as you know the portfolio weights. Right? So basically, the beta of a portfolio is the weighted average beta of the investments in the portfolio. So here you can see that what you need to do is you would use portfolio of stock I, XI, times the beta of stock I. And then you will do the same for all different investments in your portfolio. And then you will add up these values. This essentially gives you the beta of the portfolio. Okay. Now let's look at this example here. Suppose Pfizer's stock has a beta of 0.5. Home Depot's beta is 1.25. If the risk-free rate is 4% and the expected return of the market portfolio is 10%, what is the expected return of the equally weighted portfolio of Pfizer and Home Depot according to Kapam? So now we're looking at a equally weighted portfolio. So let's first look for the portfolio's beta, right? And we have just learned about this formula here, right? So it's easy to find out the beta here. Well, it's equally weighted, so it's 1/2 times Pfizer's beta plus 1/2 times Home Depot's beta. I think this gives us, 0 something. So 0.875. And now we could use Kapam to calculate the expected return of the portfolio. Right? So expected return of RP equals risk-free rate 4% plus beta times the market return minus 4%. Right? So this gives us 9.25%. This is one way to calculate the expected return of the equally weighted portfolio. There's a second way. We could first start with the expected return of Pfizer and Home Depot, and then we could calculate the equally weighted returns. Okay, so we could start expected return of Pfizer, which is 4 plus beta times the market risk premium, which is given by 7%. And Home Depot's expected return is 4% plus 1.25, 10% minus 4%, which gives us 11.5%. And we know this portfolio is equally weighted. So you can see here, the expected return of the portfolio equals weight times 7% and another weight times 11.5%. This again gives us the same answer, which is 9.25%. So basically you can see that in the first method, right, we start with the portfolio's beta. And in the second method, we're not calculating portfolio's beta. Instead, we start individual investments expected returns. Then we could use the portfolio weights to calculate the expected return of this portfolio. Okay, that's for today's class. We will talk about the chapter review next time.